how many non-congruent triangles with perimeter 7 have integer side lengths. So this is like a counting problem, right? They want to know how many triangles satisfy this certain property. So remember that like we talked about, like one of the most like common counting strategies is casework, because a lot of times, like in questions, we want to like organize our counting carefully, right? We want to make sure we don't miss anything, we don't miss any possibilities, we don't over count any possibilities. We want to make sure our counting is like organized, so we want to like split into cases. So like we might think, okay, well, how can we split into cases? Well, we know that the perimeter of the triangle is 7, and a triangle has 3 sides. So what you can think of doing is you can do casework on what is the length of the longest side. So if we do casework on the length of the longest side, right? So if the longest side is like, well, technically the length of the longest side could be 7, but then that means the other 2 side lengths have to be 0 and 0. That doesn't make any sense. So like you can kind of disregard that. If the longest length is 6, then the sum of the other 2 lengths have to be 1. That doesn't really make sense either, because then you would have lengths 1 and 0 in the triangle. You can't really have a length of 0. That doesn't really work. So let's say we have in the triangle the longest side is 5. Well, in that case, like the sum of the other 2 side lengths has to be 2, since the perimeter is 7. The only way that can happen is if the other 2 sides are 1 and 1, right? But another reason why this doesn't work either is because of something called the triangle inequality, which states that the sum of any two sides of a triangle has to be greater than the third side. Like in this case, 1 plus 1 is 2. That's not greater than 5. You know, you can kind of visualize it, right? Like if you have like a segment of length 5, if you have 2 segments of length 1, like you can kind of think like these 2 segments of length 1, they're not long enough to like these 2 points are like not long enough to meet. Like, you know, it doesn't satisfy the triangle inequality. Like you can't form a triangle with side lengths 1, 1, and 5 because it's too short. So like that doesn't work. So even though like, you know, yeah, we found that like 5, 1, 1 theoretically could work, but it doesn't work because it fails the triangle inequality. So that doesn't work. So the next case is if the longest side length is 4, then the sum of the other 2 side lengths has to be 3. So you have to have 2 and 1. Again, this doesn't work because 2 plus 1 is 3, which is not greater than 4. So it does not satisfy the triangle inequality. So that means this also doesn't work. So the next case is if the longest side is 3. Then that tells us if the perimeter is 7, that means the sum of the other 2 side lengths has to be 4. So now we have 2 possibilities. We can have 3, 1 or 2, 2, right? And notice that like both of these satisfy the triangle inequality. For example, 3, 3, 1 and 3, 2, 2, right? These are the 2 cases we found. 3, 3, 1 forms like it works. Like it satisfies the triangle inequality. Like we can draw a triangle of side lengths 3, 3, and 1. And similarly, 2, 2, and 3. We can draw a triangle of side lengths 2, 2, and 3. Again, the reason it satisfies the triangle inequality is because if you add the 2 shortest lengths, 2 and 2, that's 4, which is greater than 3. So that means we can form the triangle. So that means we got like 2 possibilities, 2 cases in that case. Now, if the longest side was 2, we can kind of just stop here. Because if the longest side was 2, then at best, the other 2 side lengths at most can have side length 2. Then the perimeter is at most 6. But like we need the perimeter to be 7. So that tells us that the longest side length cannot be 2. So that means we can just stop our casework now. And we can find that like, you know, there are only 2 possible triangles that satisfy all the conditions. So the answer would be like choice B, which is like the right answer. Yeah, okay, so just to like briefly say again, like remember like the idea was casework, and within each case we listed out the possibilities, and we also looked at something called the triangle inequality. So just in case for those who haven't heard the triangle inequality before, basically like it's just a fancy way of saying that like if you have any triangle of side lengths like A, B, and C or something, then in order for you to be able to form a triangle, we need A plus B to be greater than C, B plus C to be greater than A, and A plus C to be greater than B. So essentially like the sum of any 2 side lengths in the triangle has to be greater than the third side. That's what the triangle inequality says.